Welcome students. In this video we're going to look at the force of friction on an inclined plane. This question says an 8.98 kilogram block is moving down an inclined plane at constant speed. The angle of the incline is 21.9 degrees with respect to the horizontal. If the coefficient of kinetic friction is 0.40, what force of friction does the block experience? So, taking a look at our picture here, we know a few things. We know that the angle is 21.9 degrees. We know that the mass of the block is 8.98 kilograms. We know that the coefficient of kinetic friction is 0.40. And that looks like what we know. So let's start out with a free body diagram and see if we can figure out a few more things. So if that's the block has a weight, force of gravity, and that force of gravity always acts straight down. It doesn't matter what the object is sitting on. If it's a slanted plane or if it's on a horizontal surface, force of gravity always pulls straight down. The normal force always acts perpendicular to the direction or to the surface. So the surface is on an angle. Our normal force is going to be perpendicular to that. So that's our normal force. Our force of friction always slows down the motion, and it says that the block is moving down the incline, so the force of friction has to move back up the incline. And it didn't say anything about an applied force, so that's what our free body diagram is going to look like. Now, we know the mass, the acceleration due to gravity. We also know negative 9.8 meters per second squared, so we can find the force of gravity. Force of gravity is mg. Force of gravity is going to be 8.98 times 9.8. Force of gravity equals 88 newtons. So there's one more thing that we've just found out. Now, on this free body diagram, we have force of friction off at an angle. Normal force is perpendicular to that. So these two would make a very good coordinate system. That would mean we'd have to find components for the force of gravity, but at least it's only one vector that we need to find components to. So we're going to define our x direction as being positive that way. We're going to define our y direction as being positive in that direction. So now we need to find our components. And I'm going to draw this out a bit different, a bit bigger, so that you can see what's happening. So our force that is parallel to the x direction, force of gravity in the x, parallel to the y direction is force of gravity in the y direction, and the resultant, or the vector, is just Fg. Now, if we were to draw that on here, Fg would be down this way, and that would be our parallel to the y direction. So this angle here is equal to this angle here, and we talked about that earlier in the lesson. So this angle up here is also 21.9 degrees. So now we have enough to figure out our components, because we just found force of gravity and we have the angle. So the x component, force of gravity in the x direction, is opposite over hypotenuse, Fg, is equal to the sine of 21.9 degrees. If we want to solve for that, we need to bring the Fg over to the other side. So we get Fg sine 21.9 degrees. And if we put that into our calculator, we get 88 times the sine of 21.9 degrees. We get 32.8 newtons for the x component. The y component is what's going to help us figure out the normal force, so we're going to need that one as well. So force of gravity in the y direction is the adjacent side over the hypotenuse, Fg. Adjacent over hypotenuse is cosine 21.9 degrees. So moving the Fg over to the other side again, Fg cos 21.9, and put that into your calculator. Gives us 81.6 newtons. So now we have the two components. We have the x component and the y component. So on our free body diagram, again, I'm going to draw this again just a bit bigger. There's our normal. There's our force of friction on the coordinate system. We found the y component of gravity, and we have the x component of gravity, which gave us the resultant force of gravity right there. So this box isn't accelerating off the surface or through the surface, so the normal force has to be equal to the force of gravity in the y direction. So we can say that our normal force has to be equal to 81.6 newtons, because it's the y component of the force of gravity. Since this block is sliding down constant speed, that constant speed means there's no acceleration, so the force of friction has to equal the x component of the force of gravity. So our force of friction has to equal 32.8 newtons, which is what we were looking for. So we didn't actually need the coefficient of kinetic friction there. We could also find it. We can see if we're right. Force of friction is equal to coefficient of kinetic friction times the normal. So force of friction equals 0.4 times by 81.6. So the force of friction is 32.64. Now if we found it that way, there is a little bit of a difference, but that's because of a rounding issue here. I did some rounding when I found the x component and the y component. Had I kept all those numbers, we should have ended up with the same answer. But we're fairly close, 32.8, 32.6. So we could have done it just solving the y component and finding the normal, multiplying by the coefficient of friction, or we could find the x component and have that equal to the force of friction because of this constant speed. And that's how you'd solve that problem.